Well, good morning, good afternoon, good evening, class. This is Mr. Errol-Senna, and today we are going to talk about unsaturated hydrocarbons. In the last lesson, we talked a little bit about, very briefly, what unsaturated hydrocarbons were, but we didn't really give them a name. We talked more about how to name alkanes, which are saturated hydrocarbons. So an unsaturated hydrocarbon, if you remember from the previous lesson, was basically a carbon chain, but the carbon, so here is this is a saturated hydrocarbon, because all the carbons only have single bonds between them, and then we assume that each carbon has a hydrogen attached to it. Well, if we're writing the full structural formula, we'll write out all the hydrogens, but if we don't write the hydrogens, we assume they're all attached to hydrogens. Now, an unsaturated hydrocarbon will be very similar to it. The only difference is that one of the carbons has a double bond, which means that it's not attached to 4 different things. There we go. It ends up being just 2 of the carbons aren't attached to 4 different things. So this is unsaturated. Okay, so that's the difference between a saturated and an unsaturated hydrocarbon, is this. That's what separates it. So basically, an unsaturated hydrocarbon is a carbon chain that contains at least 1 double bond or at least 1 triple bond. Okay, and depending on the type of double bond, whether it's a double bond or triple bond, and it gives rise to a different type of family. So let's talk about those. So saturated, I should actually write this down before we go on any further. A saturated hydrocarbon, this is what we called, these were alkanes. That's what we were naming in the previous lesson. These were alkanes. Unsaturated hydrocarbons come in 2 types. Unsaturated hydrocarbons come in either alkenes, I know it's very, very slight difference, alkenes or alkynes. There we go. Okay, and we'll explain those in just a moment. Alright, so saturated hydrocarbons are alkanes, and we named them in the previous lesson. Unsaturated hydrocarbons are either alkenes or alkynes, depending on what they are. Alright, so let's start with, what are alkenes? Alright. Alkenes are any hydrocarbon which contains at least 1 double bond. 1 double bond between carbons. 1 double bond between carbons. So the very, very simplest alkene would be an ethene, because it would be a C double bonded to a C, like that. So that is the very, very simplest. Very simplest. And we call it an ethene. Okay. So whereas saturated 2-carbon chain is called an ethane, a 2-carbon chain with a double bond is called an ethene. And the line structure that I would draw for this would basically look like this. And it looks kind of like basically a double line. Okay. The next largest one would be something like this. This is what we would call, so 3-carbon chain is usually a propane, but because we have a double bond, we call this a propene. A propene would look like this. You would have your double bond carbon and then a line like that. That's a propene. Okay. After that, we would then get the following. This is a 4-carbon chain. But notice that if I have a 4-carbon chain, my double bond can actually appear in many different places. It could appear here, or it could appear, actually then this next one is actually exactly the same as the previous, as the first one. So yeah, so this, yeah, the third one I drew is actually exactly the same thing as the first one, so I'm not going to draw that. Oops. There you go. So these are normally we would call these a 4-carbon chain, would normally called a butane, but because it has a double bond, we call it a butene. Okay. Now, how do I distinguish one butene from another butene? Well, let's number the carbons. In the first butene, carbon 1, 2, 3, 4. So, much like how we name or we number branches and we use the numbers to show where the branches are located, we can use numbers to show where the double bond is located. So in this butene, we could call this 1-butene. So the 1 tells me that the double bond is between carbons 1 and 2. And the second butene, 1, 2, 3, 4, this would be a 2-butene because the double bond is between the carbons 2 and 3. Okay. Then this is the kind of the naming convention we would follow for larger chains. So let's go through a couple examples of larger chains. Oh, before we do that though, I should draw this. 1-butene would look like this. Kind of looks like a butane, but has a double bond there. 2-butene would look like this, like that. Okay, there we go. Alright, so let's go to a couple of examples of larger chains. So let's say I have a larger chain like C, 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 double bond C, C. Okay, so we'll count the carbons. I'm going to number them this way. 1, 2, 3, 4, 5, 6, 7. So 7 carbons is usually called a heptane, but because we have that double bond, we're going to call this a heptene. Okay, and then we need to know where is that, where is the double bond located? Well, it's between the 3 and the 4 carbon, so we'll call it a 3-heptene. Okay. That's what we would do. This would be 3-heptene. Okay. Now let's try another one. Let's try a slightly longer. Oh, and I guess I should draw this in its line structure. So line structure drawing. 3-heptene would be, let's see, 1, 2, 3, 4, 5, 6, 7. When you have a double bond on carbon 1, 2, 3. Double bond there. There we go. That'll be what 3-heptene would look like. Then, let's go ahead and try another large chain. Maybe we'll do one with branches. Okay, so I can show you how to do a branched alkene. Alright. So, let's do 1, 2, 3, 4, 5. I will do a double bond there, and I'll put a single chain here. Okay. So here, I've already counted 1, 2, 3, 4, 5, 6. So this tells me that this is going to be an hexene, because I have a double bond, so this will be a hexene. Okay. The double bond is located between the 2 and the 3 carbon, so this is a 2-hexene, but we're not quite done yet because what do we have here? We have a single carbon branching off, so that's going to be a methyl. So this will be a methyl, and because it's at the 3 carbon, we call it a 3-methyl. So 3-methyl, so at the 3 carbon is a methyl group branching off. At the 2 carbon is where my double bond is, so it's a 2-hexene. There you go. And that's how we would name an alkene. Okay. So, very similar to how we would name an alkane. The only difference is the ene donates this double bond. The ene donates a double bond. Alright, so there we go. So that's what an alkene is. An alkene is a hydrocarbon chain which contains at least one double bond. Alright, now an alkyne. If an alkene contains double bonds, an alkyne contains at least one triple bond. One triple bond between carbons. Okay, so the easiest, simplest one would be a 2-carbon triple bonded like that. Now 2 carbons triple bonded is usually an eth, but because it's a triple bond, it's not an alkane, it's not an alkene. We would call this an ethyne. Ethyne. And then the line diagram for that would just be a triple line like that. Okay. Propyne would look like this: carbon, triple bonded to another carbon, single bonded to another carbon. And this would be propyne. So very similar to naming an alkene and an alkane. The only difference is you just have an ine. This would look like this as a triple bond, like that. Notice there's a triple bond and the first one. Okay. Now how about, let's say we'll draw a butane. A butane would look like this. This is one possible form of butane. Okay. Another possible form for butane would be like this. 1, 2, 3, carbon, carbon. This would also be a butane. How do I distinguish the two? Well, how do we distinguish the butenes from each other? Okay. We would use numbers. In the first one, this is a 1-butane because the triple bond is between carbon 1 and 2. I'll number that explicitly. And the second one would be a 2-butane because it is between the carbons 2 and 3. Okay, so naming alkynes is like very similar to naming alkenes. Okay? You just have to identify where is the triple bond located. Okay. All right, let's go through some examples of longer chains to help you guys settle or get used to this. So let's say I have a chain like this. There we go. Alright, so let's count the carbons. 1, 2, 3, 4, 5, 6. So this is going to be 6-carbon chain. It's going to be hex. There's at least one triple bond, so we'll call this a hexyne. Okay. The hexyne bond appears at the 3-carbon. And we have a methyl branch. And that is appearing at the 2-carbon. So this is 2-methyl, 3-hexyne. Okay. And that is how we would name that. Alright, let's try another one. So let's try another one. Let's say I'll put it here. And then I will draw a branch there. Alright, so let's number the carbons. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 8 carbons is an oct, but because there's a triple bond, we'll call it an octyne. The triple bond occurs at the 3-carbon, so 3-octyne. At the 5-carbon, we have a 2-carbon branch. 2-carbon branches are called ethyls. That's an ethyl, and it appears at the 5-carbon. So this is a 5-ethyl, 3-octyne. Okay. I think that is probably yeah. If I renumber it, I don't think I'll get any smaller numbers. So 5-ethyl 3-octyne will work just fine. Okay. All right. There we go. So that's how you name alkenes and alkynes. Okay. Now, what happens if we have multiple double bonds or multiple triple bonds present? Okay. Well, it's actually not as difficult as it sounds. So if I have multiple double bonds, say for example in a large carbon chain like this, I could have a double bond here and a double bond there. Okay, well, let's number the carbons. 1, 2, 3, 4, 5, 6. Well, so this is going to be a hex. Okay, now, rather than writing hexene right away, because I have multiple double bonds, I've got to add something to the hexene name. Okay, And that addition is just basically a prefix. In this case, since we have two double bonds, so two double bonds, the prefix for double is we're going to use di. So we're going to call this a hexadiene. Okay, notice two double bonds means we stick a di in front. And then where the double bonds are located, we just put that in front. So this would be the double bonds are located at carbons 2 and 4. So this particular compound is called a 2,4-hexadiene because it has two double bonds. That's where we get the di from. And they're located at carbons 2 and carbons 4. Okay? So if you're dealing with multiple double bonds or multiple triple bonds, we basically just stick a prefix between the number of carbons and whether it's an ene or an yne. Okay. And if you're not sure what the other, if you have, say, 3 triple bonds or 4 bonds, 3 would be tri, 4 would be, what is 4 is tetra, 4 is tetra, 5 would be penta, 6 would be hexa, and so on. To get 7 double bonds, you need a very, very, very large chain. So 7 would be hepta, 8 would be octa, 9 would be nona, yeah, I think nona, and 10 would be deca. Okay, so these prefixes, you have multiple bonds. This is actually true for branches as well. So this is for multiple branches of the same type. So for example, like dimethyl or trimethyl, that means you have 3 of them, multiple branches of the same type. Multiple bonds of the same type. I should say not bonds, multiple double bonds. Okay, multiple double bonds. Multiple triple bonds. Oh, and for the next chapter, this will also work for things called functional groups. But functional groups we'll discuss later. So discuss this later. Okay. But you do have to know these terms. So let's use a different color. You do have to know all of these. Okay. Alright, I'll give you an example of where some of these might actually come in handy. Okay. This is going to be a very obscure example. You probably won't get this too often. Okay. So let me draw you another shape. So 1, 2, 3, 4, 5, 6, 7, and then I can do this. 2, 2, 2, 2, 2. There you go. That's the number of my carbons. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be an octane. Because notice that I have no double bonds, no triple bonds. So it's going to be an octane. Actually, no, let's throw in a double bond here. Let's just throw a double bond there. Okay. So now it's an octene. Now it's an octene. Octene. Okay. The octene, the double bond occurs between carbons 3 and 4, so we'll call that 3. So it's a 3-octene. Okay. Now notice we have we have a bunch of methyl groups. We have 1, 2, 3, 4, 5, 6 methyl groups branching off. So rather than just saying methyl, I can start off that way at least. I say methyl, but since we have 6 of them, I have to say we have hexamethyls. It's a hexamethyls. That means we have 6 methyls. And then the methyls occur at carbons 2, 3, 4, 5, 6, and 7. So the name of this particular compound would be 2, 3, 4, 5, 6, 7 hexamethyl 3-octene. Okay. And it basically tells the chemist that I have an octene, or the 3-octene. So the 3-octene tells me that I've got an 8-carbon chain with a double bond at 3. And then the 2, 3, 4, 5, 6, 7 hexamethyl tells me I have 6 methyl groups and they are located at carbons 2, 3, 4, 5, 6, and 7. Okay. That's what that name means. That's how we can write that. Okay. Alright. Let's go backwards. I have an example of going backwards. Like, let's say I give you a name and then we can write it. So let's say I give you the following name. So I go 2, 2 dimethyl. Then I have a 4 pentene. 4 pentene? Yeah, 4 pentene. Or pentyne? Let's go with a pentyne. There we go. Okay, so 2,2-dimethyl 4-pentyne. Okay, how would I draw this structure? Well, draw this first. Draw the 4-pentyne first. That means I have a 5-carbon chain. 1, 2, 3, 4, 5. And at the 4-carbon, I've got a triple bond. Triple bond like that. Okay. So 1, 2, 3, 4, 5. That's 4-pentyne. So always start off doing that. Then, at the 2-carbon, notice I've got a dimethyl. So dimethyl means I've got 2 methyl groups, and they both appear at the 2-carbon. So I can just do like this. Branch there, and a branch there. So that takes care of my 2 methyl groups, and they're both located at 2, 2. This di just tells me I've got 2 methyl groups, but I guess you don't really need it because you've got the locations of methyl groups. But it's nice to know that it actually is 2 methyl groups there, not just a weird typo. Okay, so 2, 2 dimethyl. That's 1 methyl. Whoops. That's 2 methyl. So that's my dimethyl. My 4-pentyne appears here. Okay. So this is what 2, 2 dimethyl 4-pentyne would look like. Okay. With that said, your assignment is basically complete the following. It's a very, very short assignment. Assignment complete 22.2 assessment. Jeez, I can't spell assessment. Assessment on page 703, numbers 13 to 17. Yeah, and the naming alkenes and alkynes worksheet. Yep, good luck. And if you guys need any help, you know how to contact me.